for regular users or for sort of network ops and neutrality?
You know, so I've been doing a little bit of stuff involving politics and legislation, been doing a lot of work with like the DNS world, and one of the things I've learned is people need data. People need to know what's actually going on out there if they're going to have any sort of rulemaking or policy determination. And so my hope is that we can give policymakers the data they need to determine appropriate economy-promoting behaviors at the network. It's impossible for this to happen without the data, which is why the FCC has been supporting this revolutionary effort to build apps that detect bias networks. So what I expect, and to directly answer your question, I expect to see over time some subset of the nation's DSL population and cable population to see tests deployed. So people can say, okay, so this is what this provider does, this is what this provider does.
Now in the context of policy and law, like the big Supreme Court decision with Comcast, so it sounds like Comcast would theoretically go yes or what?
Hey, I just provide the data. I get to just wear my I'm a nerd hat and say I'm going to provide the data. I don't think adequate policy can be developed when biased networks are deniable. Oh no, we absolutely would never slow down that provider by 50 milliseconds. Must be your network. You should work on that. So that's the stuff that we've got to be able to detect and new tools.
Can you explain over time how you ensure that the path is the same every time?
Sure. If you're talking to a, all right, so let's do a much simpler version of Neuter. So Neuter is at the IP layer. Let's imagine that you had so Google has its website and Bing has its website, but let's say whatever website you access, you go through a proxy server. The IP address is 1.2.3.4. Whenever 1.2.3.4 talks to your home machine, it's pretty much using a consistent route. Or if the route changes, certainly the route doesn't change based on whether you're downloading JPEGs, you're downloading HTML, or you're downloading a video off YouTube. So you can think of this proxy server as a route normalizer, where whoever you're talking to, the same server is what's giving you data. If you get data slower when you happen to be downloading stuff proxied for Google than if it's proxied for Bing, well, it's the same server, it's the same network path. The only thing different is an ISP might have a policy filter. And that's kind of the concept. So what I just told you is it will actually find stuff. That will work if you just run a HTTP proxy server and see which things proxy faster than which other things on a per packet basis. The problem with that approach is twofold. First, it's protocol specific. You know, there's more to the internet than the web. There's a lot of protocols out there, and it's very hard to emulate all of them. But it's not so hard to apply policies. The second problem is that the policy engine may not apply to all IP addresses specifically. There have been claims, unproven, unsubstantiatable until now anyway, that DSL and cable modem links might prefer DSL speed test sites. There are sites that you can go to that'll say, oh, absolutely. Here's 5 megabit a second. Here's 10 megabit a second. Look how fast we are. You only get that speed when it comes from the IP address of the DSL speed site. So the problem is that policy may not apply to all IP addresses. It may only apply to the actual, legitimate, retrievable from DNS addresses of Bing, of Google. So what we need is a system that is able to impersonate all addresses, is able to impersonate all services, and not have this big marker on it that says, I'm a proxy server, I'm not really Bing. We need the ISP to think it's really Bing so that we can actually see, okay, policy has been applied, packets are arriving slower, or they're being manage the ISP. The internet does not prevent you from using someone else's IP addresses. That is the nut of it. If you're on a cable modem link or you're on a DSL link, yeah, your cable and DSL provider can deploy a technology called URPF that makes sure that you're only sending traffic from yourself, from your assigned IP address. If they didn't do that, they wouldn't be able to manage their networks. But once you get into the core of the internet, once you're actually, really where all the bandwidth is, networks have no idea where things should be coming from or where they should be going to. So there's no filters. You can always forge another address. Now, this isn't usually a thing that is useful for web traffic, because web traffic runs over TCP. And TCP has a lot of protections in place to make sure that if you spoof your traffic, if you forge your source, you'll send out a request, and the response that comes back has some important, kind of like a connection password, if you will, as a sequence number. Normally, when you forge your address, you don't see the sequence numbers, you don't see the passwords. So you can't communicate using those alternate addresses. In the case of Neuter, however, we have both sides of the connection are, if you will, in on it. The client isn't just an accidental participant. He's leaking sequence numbers. He's proxying, he's encrypting his traffic off to the VPN node. And so because those numbers are spoofed and are sent from the client to the VPN node, to what we call a broker, the broker is able to spoof traffic, is able to forge traffic, and have all the right connection identifiers, able to have all the right passwords. Does that make sense? Go ahead.
What about IPv6?
I haven't looked at all of V6. It shouldn't matter. At this layer, it's the same game. I could probably do something slightly easier. I just haven't bothered because there aren't that many providers on V6. But yeah, I could add Neuter V6 will work out. Neuter 6.
So you said the software will be available in